Okay, doing the RLC. Okay, not RLC yet. I'm just trying to find from this table why the true positive rate 304 and false positive rate 2/5. Why are they correct and why are they not correct? I don't know. Or is it correct or isn't it correct? This table is demonstrating the use of what is called the labels, the true class labels. These are the actual labels. We know those labels, and then we will try to run algorithm to predict, do some prediction, classification, whatever you want to call it. In this case, I think it's more like prediction, like regression, because I have what is called a continuous value, zero point 0.7. Um, so it's more like, yeah, right, good. We have that under control. So when I run my algorithm, I use threshold value 0.1. It means that I'm looking at this value here. Now, what you notice with this is that these values here, you stick them as negative because you are not interested in these. Now we could start the threshold value from 0.01, which is this one. Means this would be the only value that would actually start as positive, and then we could do the true positive rate from here, and then we walk our way up to the left by increasing the threshold value. I could do this in Excel. If you want to, just send me a comment and I'll show you how this is done. So we are here. So the threshold value is 0.1. This is this value. So then we label this one as all these values here in towards the left. All of them becomes the label of 1, the class label 1. All the ones after becomes class label -1. Now we have the true labels. So what we are gonna do from here is just compare your threshold value from where your threshold value starts. We're gonna compare now whether these values, the predicted labels, whether they match the actual true labels or the actual labels. If they match, it's you think about the that table called the confusion matrix. See if it's a true positive. Is this a true positive? Oh yes, this is a true positive. So that's one. So that's one. Predicted correctly with threshold value point oh 1.0. Is this one here now? Looking at this one. Is this one predicted correctly? Sorry to say no. It's predicted as true when in fact the label, the true actual label of that class is a -1. So this here, it is a false positive. It's saying that false is false positive. I don't need to go through all these things. So that's one for the false positive. Then we go here, next one. That's another false positive predicted. So that's two for false positive. I'm tallying on a piece of paper so you wouldn't see. And then we go to here. Oh, this is a good one. It's true, and it actually at the threshold value is true. So that's two now for false positive. For true positive, sorry. And then this one is a true positive because the prediction is actually the same as the true label. So I got 3 for true positive and 2 for false positives. Okay, so my question is how did we do this? We did this 3, you have more, 3 over 4, 2 over 5. How did we get a 5 here? 1, 2, 3, 4, 5. Is that where we get it? No. We get it like looking at the true labels. Look at the true labels. Don't get confused now. Stay with me. Look at all the true labels and figure out how many of the entire list in the true labels had to be false. Now this was a false. 1, 2, 3. Okay. Let's go. 4, 5. So of your true labels, 5 should have been, so I'm writing 5, should have been -1. Now let's look for all those who should be positive. 1, 2, 3, 4. So 4. So that's how we got the true positive rate to be 3 out of the 4. Then it's 2 out of the 5. Let's move on now with a new threshold value. What do you do when you move on to a new threshold value? Simple. Um, the last threshold value, the one after it, immediately to the right, becomes negative, so all the rest down that way to the right are negative now. We are kind of like ignoring them, and we are focusing on this value and all the values before for the threshold. So the threshold is 0.2, so we are focusing from 0.2 go right up the road, and we are doing the same thing. Okay, it's predicted as 1, but it's a negative 1, so that's a false positive. This here predicted as a 1, but it's a negative 1, that's a false positive. This one is predicted as 1, and it's actually that's a true positive, so that's 1 for true positive, I'm telling. And this one is predicted as 1, and this one is 1, so it's a true positive. So now I have 2 for true positive and 2 for false positive, and I want to get a rate, so I'm going to count again. 1, 2, 3, 4, 5. So there should have been out of 5 for the false positive. So 2 out of 5, and for 1, 2, 3, 4, there was 4 positive. There was 2 out of 4. So you keep on doing this, and then we go now to 0.5. There isn't a 0.3, so we change now to 0.5. So your threshold value is 0.5. Now you would have to alright, so I'm gonna put it here in the notepad. So t equal to 0.5. There isn't a 0.3, 0.5. And then we put the 0. Let me just make it so you could see, yeah, the algorithm. A here is the algorithm function, right? Algorithm 0.7, 0.6, 0.5, 0.2. Now you get the idea. You get the idea. Nothing to say. For 0.7, we make it 1. 0.6, 1. 0.5, 1. What happens to 0.2? It becomes negative 1 because we are not interested, and every other one is, sorry, negative 1. Every other value down the road, negative 1. Okay, you keep your actual libs. Your actual libs, we had 1, 1, negative 1, negative 1. I'm just going to do this one to show you. Yeah. So sorry about the 2. I don't know why I'm putting 2. Negative 1, actual labels. Okay, binary. Now we have this, so we are going to count for 0.5. This is, it's predicted from the algorithm as a 1, but it's a negative 1, so that's a false positive. We move on to 0.6. It's predicted as a 1, and it is a 1, so that's a true positive. It's predicted as a 1 here, and it is a 1. It's another true positive. So for true positive it's 2, and for false positive it's 1. Now this doesn't change, the actual label doesn't change, so by now you should know it's 1, 2, 3, 4 for the positives, so these 2 have to be out of 4, and for the negatives it's 1, 2, 3, 4, 5 out of 5. Right, so you do this for the 6, you do this for the 7, then you get enough values to plot a graph, and you use the connecting parts of the graph to do what is called ROC curve. ROC curve. Thank you for viewing.